Today we're talking about finding equivalent ratios and using ratio tables to help solve problems. First of all, let's look at some definitions. We have equivalent ratios. These are ratios that name the same comparison. Think about it as you've got cats to dogs is equal to cats to dogs. So if you put cats on top and dogs on the bottom, this ratio has to show cats on top, dogs on the bottom. Your ratio table is just another way to organize the ratios to help you find equivalent ratios. For example, you've got cats and dogs. We have, for every 2 cats, there'll be 5 dogs. You don't know how many cats these are, but you've got 10 dogs. So I can put 2 to 5, 2 cats to 5 dogs should equal to how many cats we don't know is X, equal to 10 dogs. And that way we can solve it. When you cross multiply, very important concept number 1, we know that when we cross multiply equivalent ratios, they will equal to the same number. For example, if I have 2 to 3 is equal to 4 to 6, I can cross multiply 2 times 6 and I know I get 12, and 3 times 4 I'm going to get 12. So 12 equals 12. I know that these are equivalent ratios here. There are 2 ways to find missing items or missing numbers in equivalent fractions. You can put missing items or missing numbers depending on what we're looking for. One is to multiply both comparisons by the same number to find the missing part. For example, equivalent fractions. If I have 3 dogs and 10 cats, and I know I don't know how many cats I have, but I know that I have 20 dogs. I look at the dogs and say, from 10 dogs to 20 dogs, what did I do to 10 to get 20? I multiplied by 2. So if I multiply the bottom by 2, the denominators by 2, I need to multiply the numerators by 2. Because remember, we're just renaming, and that's what makes it an equivalent fraction. So 3 times 2 would equal to 6 cats. So what I'm actually doing is multiplying by 2 over 2, which is 1, and all it is renaming that ratio or the fraction. All right, or another way is I can cross multiply. To cross multiply the ratios and solve for the variable, you're going to solve one-step equations after that. For example, if I look at this, I can look at it and say, okay, I know that I can cross multiply these 2, and I can find out that n times 27 is 27n, and 3 times 18 is going to give me 54. Once I get it to this point, okay, I can draw my line. I know that I'm multiplying 27 times n, so I'm going to divide both sides by 27. And when I do, n is going to equal to 2. So the actual ratio would look like 2 to 3 is equal to 18 divided to 18 to 27. If I were to reduce 18 27ths or 18 to 27, it would reduce down to 2 to 3. Let's look at an example of how we're going to use this ratio table to help us solve this problem. A car can travel 220 miles in 2 hours. How far can the car go in 5 hours? So if I'm going to compare the two, I'm going to put my hours over here and the total miles that they can drive over here. So I know in 2 hours it goes 220 miles. How many hours, if I travel 5 hours, how many miles can I go? Well, I'm going to set it up into 2 ratios that are equal to each other. And I can look at this and I know that I've got 2 hours to 220 miles to 5 hours, and I don't to 5 hours, and I don't know how many miles it is. I'm trying to find the miles. So I can set it up 5 hours to however many miles that's going to be. If you look, what did I do to 2 to get 5? It's really not going to be something that I can multiply out. So cross multiplying is the easiest method to use here. I'm going to say 2 times m is going to be 2m, and I know that 220 times 5 is going to be 1,100. I'm going to divide both sides by 2 because I'm going to solve a one-step equation, and I know that the number of miles is going to be 550 miles. So when I look at m, I know that in 5 hours I will go 550 miles. All right, and that's how we're going to solve them with the table. We have several ways that we can work the table. Very important concept number 2. Sometimes you will need to work out the math facts in the problem before putting the numbers in the ratio table. For example, it says, number 1, there are 3 blue-eyed students to 8 brown-eyed students in most colleges in North Carolina. How many total students should be in a class of 9 blue-eyed students? Well, first of all, I'm going to look at the blue-eyed students, and I'm going to make this my total number of students. If I have 3 blue-eyed students and 8 brown-eyed students, the total of 3 plus 8 is going to give me 11. So I'm going to say 3 blue-eyes. There are going to be 3 blue-eyed students out of a total of 11 students. So how many 9 blue-eyed students will there be? How many total students will there be if there are 9 blue-eyed students? So I'm going to put 9 here, and the total number of students I don't know, so I'm going to put T. So the first thing I'm going to do is I'm going to say blue eyes to total number. So I'm going to write it out as blue eyes to total number of students. And that's going to equal blue eyes to number of students, okay? So when I do that, I'm going to say 3 blue eyes to a total of 11 students will equal to 9 blue eyes to a total of T students. I don't know what it is. Now in this case, it would be kind of crazy to cross multiply because I can look at 3 and tell you what I did to 3 to get 9. So what I did to 3 to get 9 was I multiplied by 3. If I multiplied the numerators by 3, I have to multiply the numerators by 3. So I know 11 times 3, T is going to be 33. So in a class that has 9 blue-eyed students, there has to be a total of 33 students in that class. So whenever I can see what I've done and what I've multiplied it by or have to divide it by, that's when you're going to look at it and just do that method instead. Let's look at this one. This is our last problem, and it's number 2. It says 14 karat gold is 14 parts pure gold and 10 parts copper. So it's not total gold, it's 14 parts pure gold plus 10 parts copper. If a jeweler has 96 ounces of 14 karat gold to make jewelry, how much pure gold does he have? So I'm going to look at this and say, okay, I've got 14 pure gold. Over here is the 14 karat gold, which is pure gold plus the copper. So I'm going to say 14 plus 10 is going to give me the pure gold plus the copper, which is a total of 24. So I had to do some math before I could fill out this table. If I want to know how much pure gold he has, and he has 96 ounces of a 14 karat gold, this is 14 karat gold column. I'm going to put 96 here because that's how many ounces he has. And I know that this is going to be the pure gold column, and this is what I'm looking for. So I'm going to put pure gold is to 14 karat gold. So this is 14 to 24 is going to be the same as G is to 96. All right, and I can look at this and say, okay, let's go ahead and cross multiply these two, because or I could say, what did I do to 24 to get 96? Is there anything times 24 that will give me 96? I know that if I multiply this by, let's see, if I multiply it by 4, let's see, 24 times 4 is 16, carry my 1, yes, that's going to give me 96. So I can multiply 14 by 4, and I know that 14 times 4 is going to be 16, carry my 1, that's going to be 56. So he's actually got 56 ounces of pure gold in all of this. You have some more word problems on this sheet, and I want you to finish those for your homework. Make sure that you set up your table correctly. Look and see if you need to add anything. Make sure that you are setting up your ratios where you've got cats to dogs is equal to cats to dogs, okay? So I'm comparing the same quantities together like so. So make sure you use your tables, work them out. Some of them are there for you. The last one is going to be a rate problem. You have to actually find out how much a single unit is going to be worth. And we'll go over that tomorrow, but try it out anyway. And I'll see you then.